In this video, we describe the direct step method to calculate an M2 water surface profile. A similar procedure is applicable for all other water surface profiles. Assume a prismatic channel with the following hydraulic data. 1. Discharge Q equal to 1,627.5 cubic meters per second. 2. Bottom width B equal 100 meters. 3. Side slope Z equals 0. 4. Bottom slope S sub O equal to 0.000197. 5. Manning's N equal 0.025. Using this data, we calculate the critical depth and normal depth. Critical depth Y sub C equal 3 meters. Normal depth Y sub N equal 8 meters. To illustrate the procedure, we choose 10 depth intervals, each of 0.5 meters, to cover the difference from critical flow 3 meters to normal flow 8 meters. At the first depth, or critical depth, for Y equal 3 meters, we calculate 1. Area. 2. Velocity. 3. Velocity head. 4. Specific head. 5. Wetted perimeter. 6. Hydraulic radius. 7. Friction slope. The second depth is equal to the first depth, 3 meters, plus the depth interval, 0.5 meters. Thus, the second depth is 3.5 meters. At the second depth, for Y equal 3.5 meters, we calculate 1. Area. 2. Velocity. 3. Velocity head. 4. Specific head. 5. Wetted perimeter. 6. Hydraulic radius. 7. Friction slope. The average friction slope between the two cross sections with depths of 3 meters and 3.5 meters is the friction slope is the conservation of energy between the two cross sections is Therefore, the distance increment along the channel is in which S sub f is the average friction slope along the distance increment. The sign of the distance increment is the sign of the denominator. In the case of the M2 profile, it is negative, meaning the calculation proceeds upstream from a control section. Returning to our example, the specific head difference is the distance increment delta L is This is the distance increment between the depths of 3 meters and 3.5 meters. Now calculate the hydraulic variables for the depth of 4 meters. Then calculate the distance increment between 3.5 and 4 meters. The new distance increment is the cumulative distance between the depth of 3 meters and the depth of 4 meters is This table shows the completed sample calculation of the M2 water surface profile. Note that by using 10 depth intervals, the total length of the M2 profile is 35,200.8 meters. Yet the calculation is sensitive to the chosen number of depth intervals. If we use 100 depth intervals, the total length of the profile is 65,029.3 meters. This result stresses the importance of using very small depth intervals in order to guarantee accuracy.